So we're going to look at the graphing required here for junior cert questions. Graphing linear equations. Try to get good at drawing an x and y axis. You're going to use a ruler at home. I don't have that option on the screen here, but if I just try and do even spaces between these and always label your axis, my x-axis and my y-axis. I'm going to start with a couple of equations, the easiest ones to graph. So you can pause this video and do a graph this size. I won't do any negatives yet. So let's look at the graph y is equal to 3. Sorry, the equation y is equal to 3. Now, we know that y is equal to 3 here at this point. But y is also equal to 3 here at the point 1, 3. At the point here 2, 3. At what will be minus 1, 3. So if we connect these dots, the line y is equal to 3 has no x. There's no x component. And the slope of this line, m slope, is equal to 0 because there's no rise and there's no run. Well, there is a run, but there's no rise. Okay, so a line parallel to x-axis, the slope is equal to 0. A very important thing to know. So let's start with that one. Okay, I'll do a graph x is equal to, and then you guys do 2. X is equal to 5. So here's x is equal to 5. But x is also equal to 5 here. What point is that? That's the point of 5, 3 up here. It's the point of intersection between the line x is equal to 5 and y is equal to 3. We have our point 5, 3. You can see x is 5 and y was 3. So pause the video and graph the following two lines. X equals 2 and y equals 1. Okay, so you graph these. Hopefully they look like this. X is equal to 2. Where is x equal to 2 there? Anytime we're graphing a linear equation, we just need 2 points. And then we need to connect them. And we just draw the line in this part of the graph. We will be told where to draw the line. They'll restrict the domain. The x values are the domain, which will give us a range, which are the y values. The graph y is equal to 1. Well, y is equal to 1 here. It's also equal to 1 here. Also equal to 1 here. So the line y is equal to 1. And anytime you graph something, write down beside the graph what it is you have graphed. So for my blue line, y is equal to 3. And for my red line, x is equal to 5. So try this again. Draw a graph. Graph some lines. Y equals x equals. And then the next part of the lesson we'll look at when we have both an x and y component. Okay, before we move on, let's just look at the slope of this line. If we take the 2 points on that line that we drew, we took the point 2, 0, and we took the point 2, 3. If we use the formula for slope, y2 minus y1 over x2 minus x1, we'll see that the values we get will be 3 minus 0 over 2 minus 2, which is 3 over 0. And we know that you cannot divide a number by 0, so the slope of a line that's parallel to the y-axis is undefined. Undefined slope. So again, before we get into domain and range, we're going to just graph some easy lines to graph. So there's no number in front of x or y here, they're just one x and one y. So let's have a go at drawing a graph. Now, before we scale the graph, let's figure out 2 points on each line. So they will normally tell us the line is a letter. So the letter L and M for these two lines. The easiest way to graph any linear is to just create 2 points like this Give your x value 0 and a y value of 0. And we'll get the points where they cross these axes. These are the four parts of the graph, positive and negative x and y. So if x is 0 here, this is 0, you can just read what's left, y equals 5. And similarly, if y is 0, you could read what's left, x is equal to 5. So I'm just going to sketch these. I'm not going to put all the values for x and y on. Let's just say that that's an even distance from the origin. I'm just going to put a 5 here and a 5 here. Let's look at the second line. X minus y is equal to 0. So if x is 0, and y is 0, well, look what's left. If x is 0, we get minus y is equal to 0, or y is equal to 0. And the same for what x. So we've just gotten the same 2 points here, which is what we were looking for. Because this line x minus y is equal to 0 is the same as the line x is equal to y. So all along the graph, the x and y values are the same. So the point 1, 1, 2, 2, 3, 3, minus 1, and so on. Now this graph looks like this. So this is the graph of x is equal to y. Because x and y would be the same, these angles would be 45 degrees. And so would these two angles down here be 45 degrees. So the line x is equal to y. X is equal to minus y. Have a look at x is equal to minus y. Will the point 0, 0 be on that graph? It surely will. So that's 1 point we have. Now let's pick another one. We can pick any value for x. Let's pick the point 3 for x. What would y be equal to? If x is 3, we're left with 3 is equal to minus y, so y is equal to minus 3. So 3 minus 3, we approximate 3 to be about here, and minus 3 to be about here. So we have our 2 points going down that way. So this is the line. X is equal to minus y. Or y is equal to minus x. Now in coordinate geometry we're going to see the slope of this line is minus 1. And the slope of this line, the coefficient of x, slope of this line is equal to 1. So practice graphing these lines again. X plus y equals 5, or change it to x plus y is equal to 4. The coordinates of the intercepts will be 4 and 4. Before moving on to the next part, when we will have numbers in front of x and numbers in front of y. Okay, let's move on to these two lines, C and D. Y-axis, x-axis, x, y. So let's get my points. 2 points to draw a line. There's no point in getting any more. When x is 0, let's read what's left. Y is equal to 6. When y is 0, if you want to do the maths, when y is 0, what's left is 2x equals 6. X is 3. So 0 on the x, 6 on the y. I'm going to approximate it to be here. And then 3 about halfway if we keep the same scale, half of the distance from here to here. So approximately here, and we'll call that the number 3. And this line C has a negative slope. It's like a plane coming into land. You feel negative coming back from your holidays, then we'll feel positive going on holidays, which the next slope will have, or the next line will have a positive slope. Okay, D. Let's change colors for D. Let's do it in blue. 0, 0. Okay, when x is 0, minus 2y is equal to 4. So if you want to do the maths, minus 2y is equal to 4. So we're going to divide by minus 2, which is equal to minus 2. So y is equal to minus 2. And you can see, if you go back to the line, minus 2 by minus 2 is equal to 4. And we have when y is 0, when we can just read what's left of y disappears. If it's 0, x is equal to 4. So the point 4 on the x, 0 on the y, approximately here. So we call that the number 4. And 0 on the x minus 2 on the y is approximately here, minus 2. And if we graph that line, we're just approximating, we get something like this. Now, have a look here. What have we got between? What's this crossing point called? The point of intersection. Now, if you go back and look at some of the algebra videos, we learned how to find the point of intersection. So we're going to do that now, just to finish this video off. We have 2x plus y is equal to 6, and x minus 2y is equal to 4. So if I multiply this top line by 2, that's a 2. If I multiply the top line by 2 and bring it down here, times 2, we're going to get 4x plus 2y is equal to 12. And I write the second line underneath, x minus 2y is equal to 4. Because we now have the same coefficient for y, we can combine the two lines or add them together, and we're going to get 5x is equal to 16. So x is equal to 16 over 5, and if we decimalize that, that's 3 1/5 or 3.2. Now, does it look like our x value is 3.2? But we're just after 3, can you see that? So it's very, very close to being accurate. 3.2 is that point there on the x-axis. 3.2. Now, hopefully, if we put this into the equation, we'll get a slightly negative number for y. So let's use equation D. X minus 2y is equal to 4. X is 3.2. Minus 2y is equal to 4. So if I bring the 3.2 across, or well, if I bring the 2y across to make it positive, 2y becomes 3.2 minus 4, which is equal to minus 0.8. So y will be equal to minus 0.8 divided by 2, which is minus 0.4, which is pretty accurate. That would be somewhere, that would be the line, y is equal to 0.4. So we're sketching lines. We're not putting full scales on the diagrams. We're just sketching them. We're getting good at sketching them. So when we start going on to use notation like f of x or g of x, domain and range, you'll have the skills already to graph these lines. So practice these before moving on to the next video.